problem. So we're going to create our entity example now. And I've given it an appropriate project name and language and an extension for entities. What should the extension be? Any preferences? This is a critical decision in your language design. Could call it ent. That's probably fine. Okay, so now we get a new project. And again, we have the grammar that we can look at if we want to, but declaration, but we don't need to mess with. That gives us the standard terminals. That was actually a fairly small set of terminals. We looked at them last time. This controls how code is generated. And now we have our model. And remember, the first rule is the root. This is the name of the root of your abstract syntax tree. This is the one class that you get one instance of for each DSL program. So let's call this an entity model. And an entity model has entities plus equals entity like this. So an entity model here is a whole bunch of entities. An entity, well, let's take a look. That's what I have right here on the blackboard. Must start with entity. And it might have a name. And because it's actually the name of the thing, and I want it to be the name that gets assigned by xtext, and xtext can recognize when passing my program, I used a special attribute name. This then becomes the name of the entity metamodel object. So this is when we have an entity instance, the name in the DSL program is also the name that I wrote here can be used in the DSL program to refer to that. So I have a name. Then I might have a base. And the base has to be the name of an entity. Like this. And then I have open bracket like this. And then I have a number of members. So this. Okay, that was easy. Now members might be attributes.
Must it have a base?
I forgot the question mark. I usually, actually, whenever I do this, I always tend to forget the question mark. Not on purpose, but I always get confused afterwards. So this is the first time that we catch it on the fly. Okay, so we have relations and attributes, which can be inside this. Now an attribute, so now we have a decision to make. So an attribute, that's like age, int, and name string. Now, do we want a fixed set of types, or do we want just any name is a legal type? Any name? Okay, so then we have name is an, and then a colon, and then type is also just an identifier here. So xtext actually has ways of giving you better integration with Java. And the things you could do here to say, oh, any Java type or stuff like that. But we're not doing that here. So we're just saying any string basically. Note that I'm using the name here, but it's not going to be, it doesn't work for name resolution because I could have a person with an age and a car with an age. And then if I wrote age somewhere in the program, xtext wouldn't know which age is which, because it only has a global knowledge of names. So in a way I could also attribute name here, because it's not going to work this name here is global. Whenever I write the name of an entity, it knows which entity I'm referring to, but attributes are local to entities, presumably. That's what we usually think they are. It's okay to have an age in a person, an age in a car, and they're different ages. So the name resolution that xtext gives us doesn't work for this. So we do it like this. And now remember how I decided to put the keyword relation here. Now relate, because otherwise we would actually get remember last time we got an error when I tried to generate the parser, because it wouldn't be able to figure out which one's which. We didn't see it for this example, we will get the same thing here. I'm going to put in the relation keyword, because then when it gets to a member, if it's relation, then it's relation, otherwise it has to be an attribute. So that's an easy decision for the parser to make. When it's at this point, it knows which one's which. A relation has a name, which is an ID. I can call it name, by the way, it doesn't hurt, but it's not the same, doesn't give us the same kind of magic that it does for entities. So a relation name, then a colon, then is many, that's if there's a star, like this. And then there's a target, which is the name of an entity, or the type, I think we call it type here. And then there might be an inverse, which has some name. I think that's basically it here.
Could we allow for multiple inverse? Is many inverse?
I'm not sure if that makes sense. Let's just leave it like this for now, and we know it's easy to go and change it later on, because this is a very flexible language workbench, okay? It might make perfect sense, but right now I'm not sure. So let's just leave it like this. Okay, so now we have our entity project here. And I can do run as generate xtext artifacts. And it worked. We didn't get a parser like last time, or parser generator. And now let's generate a whole bunch of stuff. We can try it out. Run as Eclipse application. So now we create a new Java project, and this is going to be our entity test. Finish. And we're going to create a new file, and this is going to be university dot, and what is the extension? ENT. Yes. And yes, this is very important. We answer yes to this. And so now we can do our entity person. A person has an age, which is an integer, and a name, which is a string. Okay. And an entity student is a person. Interesting. Missing here for entity. I think I know what the problem is. Let's see. Okay, so it's complaining now. I made a mistake, probably because this should be legal, right? And it's saying right here, missing EOF at entity. What does EOF mean? End of file. So it was actually expecting the program to end here, where I wrote entity.
Because you need to put a plus in entities.
Yes, very good. So I'm saying here this is a list of entities, and but you're only allowed to write one entity to put into it. Okay. Now I have to. Oh. Yes, it changes. Okay. Okay. Now debugging this is different from what you're used to, and at least with the tool support that's here, I mean, you have to look at and try to understand what it does. I mean, there's no passing debugger. There could be one, it would be nice. Ah.
You must run the artifacts, right?
Yeah. Run as xtext artifacts. Okay, we're good. And run as Eclipse application. Okay. So we're good. Actually, let me just close this project.
Disappear from the top.
Yeah, I'm not sure why it does that. Okay, fine. So, and a student has an ID, which is a string, and a relation follows, which is too many courses, and has the inverse enrolled. This, or maybe I don't think I put a colon here actually, like this. And now of course it's complaining because course is not defined, because it knows about names of entities. So we do entity course, this, and the course has a title which is a string. Okay. And we have we can see, we can click on the model over here. It basically knows what's going on. But this was the parser part, and that's basically what we did yesterday. Now we want to do the generator part. For that we go into the generator package, which was generated when I did generate xtext artifacts. This is what xtext generates for you as a starting point. So this is framework, and the abstract generator must implement the toGenerate method. Resource is basically a data structure containing all meta-model objects that the parser was able to find in your program. File system access 2, which is obviously has some sort of history in the name here, is a convenient way to generate files. The context contains a bunch of other stuff that we won't talk about today. And then it suggests something here to help you get started. And we're going to use part of this. So of course we need to, what we basically want is we need each of our entity objects, or we need our entity system class. We need one of those to get started here. So we can do resource.allContents.filter type of, and now the we go back to our entity here. So this, we know we have something called an entity model. And we know so we have something called entity. So actually entity model is kind of uninteresting here from this point of view, because I mean it just has a bunch of entities, and I'm actually fine with, for every entity, generate a Java file. So I'm just going to do that here. So let's go find all of the entity objects. And now I want to make sure to import the right one, like this. That I think it's for each. And so extend also has lambdas, but they had lambdas a long time before Java had them, so their syntax is slightly different. There are a few variations as well in what you can do with them, but on the whole they resemble lambdas like you know them from Java and C#. So let's say generate entity. And so generate entity is, and it needs to write a file as well. So let's create this method. Well, that's kind of surprising. Okay, no, I'm fine. It was just the extension stuff that was a little bit, didn't completely get it correctly. So now we have this method that, or let's just generate entity. Let's call it entity file. Yeah. Because then we want to do the fsa.generate file. The name of the file should be e.name plus .java. And what to put inside the file, then we're going to do .e.generate entity, which is the generate entity I have up here. So a generate entity, and now I have my templating here. That's going to be public. So this is the stuff I have here in the middle of the blackboard. Public class, and the shortcut to get the GMA characters, that's control less than, control greater than. So this is entity.name, and then we have the if. Entity.base is different from null. Then we want to put extends and see how I remember to put a space here, because otherwise you get one long name which just extends mixed into a name. Extends entity.base.name. Keep in mind that if you wrote just entity.base here, then you would be calling the toString method on the eCore object of type entity, which gives you a weird internal thing. So when in the middle of your generated program you get these weird internal things, it's usually because you forgot to say .name, just by experience. End if. Okay. So and then in here we want to say for m in entity dot, I think we call it members, right? Members here. So again, I'm looking at my xtext grammar to know what are the fields that are available in my meta model, because it's generated directly from it. So entity.members, m.generate member, and n4.
Got the end brackets above. M generate member.
Ah. xtext can be a little annoying when you want to get a close Gmail character. So let's just see. It might so and the okay. So note how the coloring here is used to show that this is an indentation that's going to be generated. Whereas these lines, because they're not going to appear in the output program, they're just for running the for loop, nothing's going to happen here. Generate member. Now we want to do the def dispatch generate member, and we want, if it's an attribute like this. And now we want to generate import attribute and we want the right one. So you'll find that extend isn't as good at all of the, whatever you call it, IntelliSense automatically dotting stuff for you as you used to. But in the rest of your life, whenever you're going to be using more specialized languages, that will almost always be the case. Usually you will not get as good support from your IDE as you used to in C# or Java, because it's an incredible amount of work to get that. And usually for more specialized languages, we're not going to invest that much into it. So for attribute and for relation, we import relation. Okay, and I'm just going to implement the attribute for now, and then we'll save the relation just for afterwards. So generate member with an attribute. So for an attribute we have, let's go look, a name and type. So this is Java, so I need to insert the type first. I'm assuming that the types that are right are legal Java types. Of course, here we get into, again, what does it mean to write a type, and we're just going to keep it simple for now. So we're just going to say that, oh, there's an attribute dot type, and then in Java we need a space, and then the attribute dot the name, a name, what it's called, and then a semicolon. And it should be private, like this. And then I want to generate a getter. So this is the get, and then attribute dot a name. So this is, of course, if the attribute is called age, it's now going to be get age with a small a. So it would be like get age like this. And of course, in Java, I would prefer to look like this with camel case. And as far as I remember, there's a method. Yeah, so there's an extension method called toFirstUpper. So this is a method that takes a string as an argument and returns a string. And because it's an extension method, you can use it on a string. So, like it or not, but this means you get a whole bunch of dot, which might be nicer than wrapping them in method calls. Again, it's a matter of taste. So, the getter here should have a type. So this is the attribute.type, like this. Okay, get, so this will get age, open close, return the name of the attribute like this, yeah, and a semicolon. Okay, and now I want to generate a setter method as well. So public, this is a void method, set, same stuff here again as this one. The type should be this type here. Now I have to be a little bit careful, because now I have to think about what should be the name of the parameter. Okay, so up here I called it x. So let me just go with that for a moment. So can anyone
Why wouldn't you just use this?
Sorry?
Why wouldn't you just use this dot attribute name now instead? Then you don't need to worry about whether or not you call the variable x.
What if there was a class called x?
Doesn't it fail because it's not an attribute type?
That would then this program would be legal. But then I mean there are all kinds of small. So for example, but yes, it's a good point. Saying this dot the name means that if the attribute was called x, it wouldn't be x equals x. Then it's going to be this dot x equals x, which is fine. Something we sometimes do is that actually doesn't matter what the name of the attribute is. So we can also put an underscore in front of it, like this, to further reduce the risk of conflicts. Suppose I had an attribute called while. While is a keyword in Java, then that would be legal. But if I put an underscore in front, it's actually okay. So that can be an advantage sometimes to do it like this. I think this is pretty close. I'm going to, for the member, I'm just going to generate a comment that is relation.rname, like this. So I'm waiting with those because we have to go see if this works, right? So I have my generator here. Let's do run as Eclipse application. Oh, it's already in use. I left it here. Run as Eclipse application. Okay. So the generator that we just implemented runs whenever we save the program here. It also means that by default it doesn't run when you just start up Eclipse. It doesn't run all generators for all programs. So now I've changed it. I mean, actually I didn't make a change, but I just made a small change and then so I can save it. And now we get a new folder here, source gen, which has 3 Java files: course, person, and student. This is exciting. Let's go see if it works. So this is public class person with age, set age, name. We have the student person, private, public. So let's build path, user source folder. Then is a source folder. It actually, there are a few things that Eclipse doesn't check if it's not a source folder. So it can be nice to make it a source folder because then it actually checks everything. But this program actually works, or at least it's legal Java code. And I'm pretty sure it works with how simple it is. So that was the basic generator. Having the source code already makes it much easier to write the generator. What I sometimes do when I write generators is that I take the source code and paste it into the template. So I have a complete template which is just one program, like the student up here, generated. And then I start to go and look for the places that must be different with every DSL program. Like, the name should be different every time, of course. That can sometimes be easier, but it depends on how you like to work. We have time to look at the relation as well, so let's just look at that. Now for the relation, we have to decide now on what representation to use. I'm thinking we'll just go with a list to be simple. So let's make it private list of relation, and now this is going to be the name of the entity. So this is the name.type relation.type.name, like this, and then underscore relation.rname equals new array list, like this.
You have to put a type. Oh, you did that.
Not for,
Yeah, so this means that it automatically infers it because it's completely obvious what should be here. And now we want getters and setters. So now we also have to decide on what does a getter give us. Does it just give us the data structure? But of course then it means we're exposing our representation. That's actually bad programming. We could expose one element at a time, or I mean there are many different options. And do we want to show how we actually, let's say that we get a collection back because we don't want to expose that it's actually a list. So we get a collection, the getter method is going to give us a collection of the stuff, get, and now I have, it's actually the same thing here. So this is the relation.rname.toFirstUpper, like this. So this is the getter method. And we're going to, as far as I remember, I can do new array list. I need a return new array list. Probably need to put the type here. And then with the name here. Does anyone remember, is that I think that's a constructor on the Java list, right? You can make a list from the contents of another collection, right? Does it seem reasonable? Well, let's try and generate the code and see what. So the reason I'm doing this, of course, is now whenever you call get whatever, you get a copy of my collection. So if you go and modify it, it doesn't mess with my own representation. And then we want, so we probably don't want a setter because we don't want to, maybe we want something like you can add something to the collection and remove. So we want probably add add to this relation, and you give it x like this. So we add something to this, and to do that we do that add of x like this. And then we want a remove method. I'm guessing it's probably going to do pretty much the same. And I think it's called remove for lists in Java as well. Of course, the remove in Java list has a very specific semantics, which might or might not be what we actually want for our own collections. What if there are multiple occurrences of it in the list? But let's just leave that for now. But I think an important point here is, of course, that suppose we at some point want to decide on a different representation. Let's say we want, we should be using sets for this. And we decide that, this is what we want in all of our programs. Now, if we had been writing these entity classes by hand, we would have to go and modify each Java source file. Now we just have to modify the generator and then generate the files again. And all of them have the same and updated semantics. Note that I'm not taking care of the inverse relation here. This is just the one way. Oh, and this is actually only if it's a many relation, right? So this should say if relation dot, let's look, is many, yeah, then this whole bunch of stuff here. Else, and else it's actually going to be a lot like this code here. I could probably have made a copy pasting is bad, of course, so you shouldn't do this yourself. I could have made a more general version of the attribute generator that I could use in both cases, but I'm just going to do it quickly like this. Dot type dot name. So that this code is not going to work actually. It's going to be illegal. It's actually very close, but there's something missing. Can anyone see what's missing? Yeah?
I was thinking about what you're going to do with the inverse one. Because that one.
Yeah, we're leaving the inverse for now. We'll do that later. Anyway, this one's good, so let's try and run it. So run as Eclipse application. So there's at least one problem. There might be more. So I have my university here. I modify, save it, and I was right. So the course and the person are fine. What's missing? What's the problem? Imports. Yes. So we need to put an import in there. So let's go do that. So now we kind of have a problem. At least it depends on how we want to think about this. So it's only if we have a relation which is of the is many type that we need an import. But when we're generating this code here, we're down in the middle of the body of that. Or somewhere else, we're not at the top of the class. If we want to do it at the top of the class, it's up here. So we could write a clever small piece of code, and this is Extend is actually heavily optimized for writing these clever things you can do with lambdas and everything. You could write a really clever piece of wonderfully lambdafied code that would say if there's one of the entities that has as many or not. So that would be very satisfying, and we could do that. We could also just do import java.util.star. Right? And we're just going to do that in any case because it doesn't matter. So we're just going to do that now. And of course that's not, so by the way, Eclipse will but it's not, it tends to be willing to reload the generator, but it depends a little bit. So I usually, just to be sure here, I'm quitting it here every time, but when you're working with it, you don't always need to do that. So we now need to force the generator to run again. There's also a shortcut for that, but just modifying and changing it is easy, and now it works. We have import java.util.star, which of course is redundant in many cases, but it's okay here. So